Hi everyone, thanks for having me. Well, I'm Kevin. I'm a blockchain engineer myself. I've developed smart contracts over the past years as well for Boba Network. And in general, I'm responsible for a lot of things that go on the hybrid compute front, especially when it comes to the application facing side of things. In general, to kick this off, not sure how familiar everyone is with Boba Network itself. Boba is optimistic rollup based on the Optimism architecture. And we basically added hybrid compute to the stack, which allows you to request off-chain data in one single transaction, right? You basically, just like with oracles, where you have to wait for the data, with hybrid compute, you directly in a serial way can work with the data in the same transaction and can do a lot of cool stuff, especially on the AI front as well. And that's basically what we have built, right? So just to give you an idea for the first use case before we go into the details, we, for example, have an example project where you basically type in, just like with ChatGPT, you say, hey, please send Kevin like 1 ETH or something like that. And it will do that. Or if you provide a wallet address, for example, right? And these kind of things are possible with hybrid compute, right? So you can actually utilize Gen AI in a lot of creative ways. So before we start out, have we got any questions here? Not sure if people have spent some time already with hybrid compute. If so, feel free to drop your questions at any point of time. Happy to answer them. Otherwise, I would share my screen and let's go. So hybrid compute, as we already heard now, is basically a connector between Web 3 and Web 2, right? The Web 2 part can be any API you can imagine. It could be the Twitter, X API. It could be ChatGPT, Claude, Perplexity, whatever you want to use, right? It could be some image generating AI for your NFTs, whatever, right? So your imagination has no boundaries on that front. And hybrid compute, like we used to have hybrid compute like a V1 back then, just in case you stumble across it somewhere. But our new V2 hybrid compute utilizes account abstraction. That's why you see me now talking about account abstraction as well, so that we are all on the same page, right? So just in rough terms, what is account abstraction? In really quick, because I'm sure a lot of people have heard of it and have some context around it. It's a story about two accounts, right? Right now, a lot of people, or most people, still have EOAs, externally owned accounts, which means you have your MetaMask, you have your Phantom wallet, whatever, and you have a seed phrase, 12 to 24 words. Usually, you have private keys, and if you lose them, well, have fun searching for it on the landfill, right? So that's kind of how it used to work and works for a lot of people. And then on the other hand, you of course have contract accounts. These are smart contracts that are code essentially, but cannot sign transactions by themselves, right? So what's your blockchain identity? Let's briefly talk about that. We've heard now it's about private keys, right? And your private key basically is your access to your identity, right? It proves that you own this account. So an externally owned account basically is about your key identity ownership, because you have to own that private key in order to prove that this is your identity, right? With account abstraction, you decouple these kind of things, and you now have a key that is decoupled from the identity and ownership, right? So what can we do with it? You have these social recovery mechanisms that we have heard about. You have Google authentication. We have all these kind of things that enable you to access your wallet without actually keeping track of your seed phrase or private key. So aside from that, of course, you can do a lot of other cool stuff that you most likely have heard about already. Like aside from social recovery, when you lose your private key, you can add other authentication methods as well, not just these OAuth authentication. You can use your own email-based authentication models too. And you, of course, can do these fancy UX things like paying for transaction fees, paying gas in tokens, like your own project token, for example. You can set transaction limits, multiple signers, like for multi-sig wallet, all these kind of things, right? So a lot of cool UX features. And also here, you have no boundaries on that front. But that's a kind of abstraction, right? But how does it work anyway? On a real quick thing, like what do we have? And that will also explain how hybrid compute works. A kind of abstraction needs a bundler, right? At least one. And that bundler basically is a server, a program, an application, right? That handles user operations. And user operations in its most simple terms is nothing else than a transaction, right? It's not a transaction in the blockchain sense of things, but from its structure and purpose, it is a transaction, right? You have the same information basically along with other parameters that you submit to the bundler, and the bundler then actually sends the transaction on chain, right? So the bundler is some kind of an intermediary on that front that is compliant with the ERC 4337 standard. And as you can imagine, account abstraction, like with all these fancy UX features that we have already heard about, from paying gas and like paying the gas for users or paying with tokens and all these kind of things, you can plug into a lot of cool stuff. Like as we have heard, social recovery, ledger recovery being a fancy, well-known and hated use case, I would say. If it's done since it's very modular and flexible, you can do basically anything with it, right? So this is not exclusive to Boba. It's really just a kind of abstraction, and you can do that on every network that offers a kind of abstraction. And as mentioned before, you basically have this decoupling from identity and access to your wallet, right? Where you have social recovery, authentication models with Google Auth, Facebook Auth, whatever you want to use. And that then gives you access to your funds. So just as a quick recap, we have autopay, pre-approved transactions, bundle transactions, basically just making the look and feel better when it comes to interacting with on-chain smart contracts. Or you also have this pain of onboarding new users, right? You can mitigate that by basically completely abolishing the need of writing down seed phrases, or when you lose your private key or your seed phrase, that you still have a way to regain access to your wallet by using multi-factor authentication and other social recovery mechanisms, for example. And as mentioned before, you can also pay in tokens or subsidized gas for users. So this whole onboarding pain that we used to have for a long time and still have, of course. So it's not a silver bullet for everything, but it really significantly can decrease the barrier of entry for your users, basically. One heavily neglected advantage of account abstraction itself is that you actually reduce human error, right? Because people are people, they're humans, right? And everyone forgets something, everyone loses something. And I'm pretty sure everyone has forgotten a password in their lives, but especially if it's an old password, like 5 years ago. And these things happen, right? A lot of people lose access to their wallets, right? Especially if you have a lot of wallets. So this really helps with that as well. And due to the modularity of account abstraction, you have a way of introducing a lot of innovative models. You can do a lot of crazy stuff with it because it's essentially a smart contract, right? You can implement any feature you want, right? It's like a programmable account now, and that's kind of a cool thing. And like you basically can also mimic our traditional means of payment as well, like when you have a bank account on a traditional bank with daily transaction limits and account freezing if you feel like someone got access to it, whitelisting, like, okay, I only want people to receive funds from my account if they're whitelisted on my smart contract and all these kind of things, right? So that's basically the main advantages of account abstraction itself. And here, just again, you basically can bridge the gap between no coiners and dApps by just jumping, like not forcing users to jump through all these hoops of funding their wallet through a fiat gateway or something like that, or worse, an exchange and all these kind of things, right? So that's just a general flow of how this works, or usually works, right? You have to store the private key, purchase funds, transfer them, and then pay gas fees for it, wait for it, and it's just a really cumbersome process. I just helped an artist last week to exit some of their NFT revenues, and it's still a pain, right? If you don't have that. So let's go to hybrid compute. Right, we have heard now account abstraction basically allows you to do a lot of crazy stuff. And we basically thought, well, account abstraction definitely is the future, right? And we're going to bet big on it. And so what we did is we converted our hybrid compute V1, which was basically more tightly integrated into our layer 2 itself, which means we had integrated it into GAF or then Aragon as we switched at a later point of time. But now it's based on account abstraction with our V2, which means hybrid compute is built into our bundler, into account abstraction itself, right? So that means there have been less changes on the, let's say, protocol side of things, like on the layer 2 infra side of things, and it's more modular as well, right? So that's basically the big change from V1 to V2 now. And hybrid compute now basically is a feature on your account abstraction wallet. Let's put it that way, right? So what you can do now is you can create smart wallets, account abstraction wallets that, for example, are based on off-chain data, right? Especially when it comes to social recovery, as we see here, right? You could more seamlessly integrate, for example, social media accounts to restore your account access and all these kind of things, right? And that's pretty cool. Or you can create social graphs, like that whole soul-bound token thing that we used to talk about a lot in the past. You could do that with hybrid compute, right? A lot of cool things because you don't have to wait for the data. It's basically just a call you make on your smart contract. In the next line of code, you can directly access the data, which is pretty cool. Like here again, basically social media recovery, right? Basically forcing people to just post on Twitter, right? That's my wallet. Okay, well, that's a maybe simple or naive approach to validate if you own that account, of course, but it can be as easy as that, right? And well, MPC, multi-party computation in general, works differently than account abstraction, right? This is independent from hybrid compute, but MPC basically, in its simplest terms, just works like you have a private key, you have a seed or whatever, and you distribute it across different parties, right? You have one located on your device. One is being managed, for example, maybe by Web3 Auth or whoever, Metric Link, and one maybe is managed somewhere else or whatever, right? Something like that, or by a friend of yours, or you have more key shares. That's in its simplest terms, MPC. And account abstraction basically is a new way of how we manage accounts. right? You don't need to integrate these social recovery mechanisms on a account abstraction, but you can, right? Because we have that decoupling. Like you basically, it's just more modular, and you can use whatever you want to, right? So it's just let's consider it a V2, right? So a lot of these MPC providers, Web3 of Magic, Third Web, they also offer account abstraction now as well, right? So that's kind of how it went with these providers. Of course, they still do MPC, but yeah. And it's not to say that MPC is outdated or something. It's just a different approach. But yeah, that's basically about social recovery. So you could say, okay, as long as I got access to two social media accounts, I still can recover my account. Right? And that, of course, can be easily validated through HybridCompute. Right? So that's one way to think about it. And through that seamless integration with the Web2 world, right, you can enable more creative and more user-friendly use cases. Right? Again, you have account abstraction, which is already focused at UX. And then you have HybridCompute that also does that. And you bring these two things together, and then you have just awesomeness, right? You have something that feels natural, like you can actually build Web2 experiences on blockchain, and you don't have to become highly centralized in order to do that. And that's kind of a cool thing. That makes your application, of course, much more accessible, right, to a broader audience. And that's, of course, always one thing that we want. We want a lot of people to use what we have built. And since you have account abstraction and can enable these recovery mechanisms, you also can minimize fraud and counterfeit, and like other UX features like gasless transactions and batching transactions. Like, for example, if you know you want to do like 5 things now, why not compress it into one transaction or less transactions, which also makes a better UX, right? So that's kind of what you can do with it. But yeah, before we go into the technicalities, because I assume most people are developers here or people that watch this, so you want to have something to grasp, like how does it actually work? Do we have any questions at that point before we go into details? Does I can't read it here. Sorry. Does Boba account abstraction support Wallet Connect? Well, in general, with Boba account abstraction, you can build whatever you want, right? If your question is like, do we have a Wallet Connect example or something like that? No. But or like, what do you mean? Like just connecting your wallet with Wallet Connect? Like basically, like if Wallet Connect supports account abstraction, like connecting your account abstraction wallet, of course you can, right? So it's more kind of an integration kind of thing. But I would need to check that with BD to not say anything wrong here. Okay. If we have account abstraction, does this mean that we can also submit transactions through HTTP API requests without going through signing transaction with private key? Well, HybridCompute is still triggered by a smart contract, right? And smart contracts need to be triggered by a wallet. So that means like when you engage with your wallet and the HybridCompute enabled smart contract, you still need to submit a transaction, right? And that transaction can be submitted, of course, through a much more user-friendly way, right? Because you don't have to pay gas for it, because it's account abstraction, because you don't have to manage your own private key or seed phrase, right? Because it's account abstraction. So it's kind of just a combination of those two things kind of enables you to submit transaction through HTTP, yes, but you still have MetaMask popping up, right? For example, because you have to send your user operation to the bundler, and the bundler then does the rest. So that's kind of how account abstraction works. who will be paying gas fees for using account abstraction. Will Boba support this, or they have to top up? If in the contract, great question. I mean, just like with every account abstraction, it's up to the project itself, right? Like if you build on Boba, like for example, you build a DEX or like a lending protocol, you could use account abstraction with HybridCompute there to allow users to trade without paying for gas fees. That works, but you as a project owner need to provide the gas. Like you basically have a wallet or something like that, and it's being deducted there. That's kind of how it would go. So it's not Boba itself. Boba is just providing the infrastructure for you to build that stuff. Right? So that's kind of the account abstraction standard. I hope that answers the question. Cool. Well, then let's dive into the tech stuff. In general, we have 3 SDKs. One for the front end, two for the back end actually, and one for the smart contract. Because if we think about it, like what do we need? But the first thing that we have is a smart contract, of course. Right? We have a smart contract that wants to talk with the off-chain world, that wants to talk with ChatGPT, for example. Right? So we need a smart contract. And for that reason, we have a smart contract SDK to make it really easy for you. That's the first part. The second part will be a front end. Right? You don't want users to go to the block explorer and execute your smart contract manually. That's not user friendly, right? That's not a goal. We want to be easily able to have users engaging with your D app and that you're engaging with your HybridCompute enabled smart contract. For that reason, we have a simple front-end SDK as well. And now the third SDK is on the backend side of things, which is basically just doing the off-chain stuff that you want to happen, which means if your smart contract, for example, should generate some kind of ChatGPT response to your prompt that you submitted on-chain, then your backend basically makes the ChatGPT request, and that backend returns the result in an encoded way to the smart contract. Right? So here we have a TypeScript SDK, and we do have a Python SDK as well for people that prefer that. So those are the 3 things that we have available. You don't need to use them, but it's highly recommended because it makes things a ton easier. And you're always up to date, right? And as of today, HybridCompute is only available on testnet, Boba Sepolia, but we're already in the process of migrating HybridCompute to mainnet. So that shouldn't take too long, right? But I have no official announcement on top of my head, like when we think this will be live. But I don't think it will take longer than a month. But please take it with a grain of salt, right? I have no idea. So let's get into it. On the smart contract side, which might be the more burning question, you basically have to add 2 things, right? And I also have code examples here, right, to make it easier to digest. But in your smart contract, you need to define a hybrid account. And the hybrid account basically is such a smart account. Also your own, also as a developer, you have a smart account as well. And that is HybridCompute enabled, right? Which means it's just an account, a smart contract that you have to deploy. And we need to add that into your actual smart contract, right? To, for example, to then actually talk with your with the off-chain world, right? So that's this part, this single line. You have a hybrid account. This is really just you import that from the SDK, and you have your address here, right? You can provide that in the constructor, or you basically just define it hard coded Here's our, okay, that's a little bit small. Let me try to make that bigger. Okay. Well, let me check that afterwards. Didn't think about that this is too small, or can you read it? This is basically that part, right? We have the constructor, also that could be your smart contract, right? This smart contract can talk with the off-chain world. So we have this part, we basically just define a hybrid account here. And here, that's the next part. This will be a function that uses or talks with the off-chain world. But let's go back to the slide for a second. All right. So what we need to do is we basically have this single line of code that defines which backend function we want to call. Right. On the backend, we have named it get price, and we ask for a string. Right. We basically want to request the price from an off-chain API like CoinGecko, for example, stating, okay, for this token, whatever this may be, could be even a Solana token, by the way, but you could provide, like on your EVM network, you could provide a Solana address here and request the price of Popcat, whatever you want to do, right? And that's basically how we form the request. We say which function do we want to call on a backend, which token, like what's the parameter that this function expects on a backend. And then we have a mandatory line that basically just says, okay, who is sending that request? So you basically just encode your the MSG sender, the one that is triggering that function. And then we make the actual off-chain call, right? This HA, as we can see here above, is basically just our hybrid account. And this smart contract has this call off-chain function method that asks us to provide this user key, like who is making that request and what is the request. And the request being, okay, we want to call that get price function that we have defined on our backend with that parameter. And that's it, right? When you call that function directly in the next line of code, you can do whatever you want to do, right? You can or should check if the off-chain API returned you some kind of error, or also like if no error happened, you of course want to decode the result, right? Because you get here a bytes parameter. You basically want to decode what is in there. We just return one value, which is a string, which is the price of Popcat, for example, again. And then you have it, right? It's really, that's the same code here, like except of the error handling. We make the off-chain request here in one line of code, basically, and have the result directly in the next line of code. So it's really just one smart contract call. You don't need to recheck on the front end all the time if the data has arrived or something like that. It's there, right? So that's the idea. That's a smart contract side of things, right? And that really is everything that is to that. We have lots of examples for that. We can go through that afterwards as well. But basically, it always looks like that, right? You form the request. You form the request here. You say who is sending that request, and then you actually make that request. If you like to have it in one line, you of course could also just move these two things into that single line of code. But for readability, of course, it might be easier to have it that way. But that's basically all it is, right? So no weird callback logic or something like that. That's a smart contract side. That's all it is, right? Basically one line of code. Then on your server, that's where the magic happens, right? Here is the TypeScript example, for example. As mentioned, we also have a Python SDK. It works identical. Of course, the syntax is a little bit different, but it's the same thing. All you need to do is It could be a Lambda function, by the way. It could be a Nest.js server, Node.js server, whatever you want to do, right? It can be really simple. Could be a simple script. But basically all you need to do is import the SDK, instantiate it, and then you basically just tell it to listen for requests, right? If you recall, we define here, okay, the get price function that expects a string. That's the ID, the identifier. You basically could write anything in there, right? But for best practice and maintainability purposes, I would strongly recommend to follow that standard. But basically, that's the same what we have here. But that's get price string, right? That's the same thing as we have here, get price string. That's where we define where this smart contract call actually goes, right? So it's an RPC call to answer your question. So basically, we define the function here, and it listens at a port, port 3000. And inside here, you can do your magic, right? You can do your ChatGPT call. You can do your Gen AI stuff. You can do store something in a centralized database if you want to. You can do whatever, right? You can request Solana price feeds, do some crazy cross-chain stuff, whatever you want to do, right? Everything. It's really, that's the Web 2 world. Everything Web 2 allows you to do, you can do here. Everything, right? And yeah, basically such as the content here that handle action could look like this, right? Here's just some code that might get you started, because if we go back here, we have our request, right, that we encode here with that token address, right? We say, okay, we gonna provide the Popcat contract address or account address here, right? And then it's being passed as within that params value. And that params, which is just named off-chain params here, sorry, which is the same thing here, we can use the SDK function get parsed request to then access that token address easily in an object-oriented way, right? So it's then really easy to just work with the token address and do your stuff here. You can do your CoinGecko request here, your ChatGPT request here, whatever, right? And once you're done with your stuff, your Twitter request, whatever, you have to encode the response for the smart contract. Also here, we have an SDK function, generate response, where you just pass your response payload, like your object, for example, your price, like the Solana price of Popcat, for example, you pass it in there, and then we just decode it for the smart contract, the SDK version, like with the SDK function, decode ABI, right? As that, you don't need to use these SDK functions. You can do it in a raw way as well. We should have some examples on that front too. But of course, I strongly recommend you to use the SDK because it abstracts like 99% of the complexity away. So again, we build our request here. We say, okay, get price is the function. It expects a string, and that string is our token address. We make the request. It goes to the backend. The backend sees, well, that's the function we want to call, get price string. Let's pass the params, which contains the Solana Popcat address, into that function, into that action. And then here, we basically parse the request to get the Solana address. We do our stuff here, and then we generate the response and return it back to the smart contract. Right? And that all it is. And then, of course, we still have our front end, which is just to invoke the smart contract. Right? And that's basically how it works. Very similar to the backend. You import the SDK, front-end SDK, instantiate it with the chain ID and your account, like basically the user account that is currently connected with the site. And then you invoke the transaction, right? So this basically opens your MetaMask, for example, and then you can submit your transaction to your user operation to the bundler, right? So that's basically how it works. You build it here, you define it. Basically, you just say, okay, which smart contract function do we want to call, which is the one that contains this code here. Again, this is this stuff, our custom action here. Basically define, okay, like just with every other DApp, you define which smart contract function do you want to call, and you provide the parameters to that smart contract function. So that's what we do here, right? In the transaction parameters, we say which smart contract, which function with which parameters do we want to call. It's typed, so that's very easy to fill out. And then you just invoke the snap, which means your MetaMask will open, say, hey, do you want to send that user operation, which will trigger the smart contract, and then as a consequence will trigger HybridCompute and so on and so forth, and your backend, right? And that's all it is, right? It fits on 3 slides, right? Like this basically is a one-liner. This is just your backend server, right? You fully define a server here. And then you have your logic, right? Which is as complex as you want it to be. It's your code. And on the front end, I wouldn't say it's much more complex than invoking any other transaction on the front end. That's it. But it's really just which smart contract and what do you want to do. On the smart contract, on the front end side, as of today, you need MetaMask Flask, which is just a development build of MetaMask. If you go into the web shop, for example, MetaMask Flask, it's this purple one. This will be changed very soon, right? We have the snap, like we like as of today, it's really just for today. You need to download this to debug your application, but only because our snap, which talks with HybridCompute, is not listed yet on the official MetaMask Snap store, right? But we are almost done with it. We are audited. We are already in the process of being listed, right? So that might be done in the next few weeks, right? It's really just a matter of weeks. Then we are listed. But yeah, just as a side note here, right? So the store listing is pending, but we're actually almost in the store. And yeah, of course, there's more documentation to it. A lot of examples, right, for different use cases, even KYC use cases, whatever you can imagine, right? You can gatekeep stuff, whatever you want to do, right? All sorts of crazy things are possible. Is HybridCompute getting data from blockchain through WebSocket or polling from repetitive HTTP query? HybridCompute is just your gateway to your own backend, right? Which means the bundler basically accesses or calls your backend, and what you do on the backend is up to you. If you want to use WebSockets, if you want to use HTTP polling, it's up to you, right? The smart contract is, of course, not a WebSocket because smart contract or blockchain itself is transactional, right? So it's a one-time thing. You do a transaction and something happens. So basically, it's a one-time thing, right? Whenever you trigger the transaction, something happens. So it's a RPC request. But on the backend side of things, you of course could do WebSockets, you could do anything, and you just have to return the data. Right? It's a pull mechanism to answer the question, kinda.
Okay, but then RPC has a WebSocket to listen to a certain contract event, right? So I was just kind of wondering, like, if there's like a hybrid compute backend, I was not sure if hybrid compute backend is actually asking RPC like for like every 6 seconds, ask if a certain like function has been executed or something, or just like other indexer, it just has a WebSocket connections to the RPC, and then they just listen to the certain contract events that happens on the hybrid computing contract and then execute it. So yeah, it's two different ways, right?
Uh, I mean, to hopefully simplify this, in the end, your backend could be a Lambda function on AWS, right? So it doesn't even have to be running, right? Which means once your smart contract is being triggered, your backend is triggered, right? So it's there's actually no WebSocket involved on that front. It's really just the trigger transaction. The RPC call is being made like with a regular push mechanism, right? You basically say, okay, something is happening, and your backend wakes up your Lambda function and returns the data, right? So if you include some WebSockets on your Lambda function on your backend, up to you, right? If you if you listen on a WebSocket for token prices, for example, you can do that and just return it in the HTTP RPC way. That's possible, of course.
I see. Yeah, well then I was just kind of worried about on how to connect then. I guess there are some certain servers just to alert the backend, I guess. And then about the sending it back to the contract, do I have to send it in a format that says the ABI encoded? So like, we can just use so in the JS backend we have this like VM library to encode as like a Solidity AVI type and then just send it to the contract, right? And then just Solidity has to decode it through AVI. Is that correct?
Absolutely.
Okay. I
Correct.
got it. All right,
Actually,
that's it.
data. Cool. Like, maybe to recap, we get the bytes data here, and we can decode it here, right? We know it's a string. We destructure it here, basically. And here, that's where we encoded it. Also encoded, actually. Let me check if that's right. But yeah, that's basically how we do it, right? Cool. Any other questions in the meantime?
I'm sorry, just again, so if I want to send back and forth some JSON file or just an object file, it seems like we have to predefine the struct type in the Solidity contract and then do it. I guess, right?
Yes and no, which means if you want to use signal values in your smart contract itself, of course, right? Because you need to destructure the JSON, the object, right? And Solidity is statically typed. So we definitely need to know how the object is being structured. But if you say, okay, I don't care, I just want to have it on chain, I'm fine with that bytes value, basically. Then of course you don't need to know its structure, right? The data is there. You can fetch it in your D app and decode it there as well, if you know what I mean.
Yeah, okay, great. Just values or so, yeah, okay.
So your data is in there, whatever structure it has. Cool. Yeah, as mentioned, a lot of documentation is here. A lot of examples too. The price fetch example that we just talked about. Simple add subtract examples. How you set up a server. Here you see the Python version, the TypeScript version. all these kind of things. And on our GitHub repo of the SDK itself, we also have a lot of examples here. For example, for Python, text to call, which is, for example, the example that allows you to just write a prompt and then a transaction is being executed on your behalf, which means, hey, send Kev 1 ETH on that wallet, for example. You can do that with this example and HybridCompute. Or we're just renaming that, but that's basically a presidential bot game. So it's GameFi. It allows you to, it's kind of a quiz, right? And that's a great example on that front as well. And we of course also have TypeScript examples. That's a rather generic template that you could use to get started. All right, so if we click here, we actually could even use this template here, right? Create new repository, and then you're completely started, right? You have a working backend, you have tests, everything runs through, and we have it documented as well, like things that you might need to do or want to do, right? For example, here we have the server action, like an example here. It's basically the price fetch example that we talked about, right? When you want to read a Solana token's value. That's kind of this example, right? So you have everything in there, and you could basically work backwards from a working project to something that you want to build, right? So it shouldn't be painful, actually. But of course, you can build it, add it to your existing project as well. So this is really just if you start from zero, you get a full stack example to get started, to make it as easy as it can be. And we, of course, are happy to create Telegram groups with you guys and help you along the way, get you started, and all that kind of stuff. But that's in general, on a high level, how HybridCompute works. 1 or 2 lines on a smart contract, creating a very, very, very simple server on a backend, and then just triggering the function on the front end. That's it, right? I said a lot of stuff, but in the end, it's once you dig a little bit into it, it shouldn't be that complicated. I hope that gave you good context. Happy to go through some specific examples as well, but I think keeping it open for some other questions too might make sense. Aside from that, thank you for your time, and I hope I didn't overload you with too much stuff. But yeah.
Cool. Thank you so much, Kevin. Does anyone have any questions about HybridCompute or how it could work for their specific projects?
Hey, so for my project, I'm a DEX. So first, I think I can set up some account abstraction with recovery functions to do. And secondly, I think I can use this account abstraction for building an automated trading fund. And then, we could actually manage users' asset without like withdrawals on their request. And then, although there are some NPC projects who are trying to solve this with the T, but then it's not really transparent. And then I believe I can use Boba account abstractions to, support these kind of problems. Yeah.
Cool stuff. Sounds exciting. We'll love to see